Hello everyone. The topic for this session is TrueCatch. TrueCatch is a new feature with Oracle 23ai database. So what is TrueCatch? TrueCatch is a memory cache. Before going to the TrueCatch, we'll learn what is cache and what are the problems of conventional caches. So why the Oracle has come up with the TrueCatch and what are advantages of the TrueCatch. So first cache. Cache is a fast memory. The cache is nothing but a fast memory storage layer that reduces the time and records needed to access frequently used data. So it's fundamental technique in system design to make applications work faster and more scalable and efficiently. So most of the modern applications use perform repetitive read operations or select run select queries on the same data. So this is the application layer. This is the application, and now here we have cache, and here we have database. Cache layer. We call it as cache layer. This is the application layer. This is the cache layer, and this is the database layer. So what happens? Most of the applications which use the cache layer, the applications communicate directly with the cache. Run any select queries or other queries with the cache, and the cache will have the most recently fetched data will be stored in the cache layer. So whenever the application requests any data from the cache layer, cache will, if the data is already available in the cache layer, it will return the output to the applications. If it is not available in the cache layer, we call it as cache miss. So at that moment, cache layer will be getting the data, pulling the data from the database, and it will send that output to the application. So why applications use cache layer? When you use cache in between the application and database, it will improve the performance by reducing the disk I/O and CPU usage on the database layer. So that is the reason they use cache layer in between application and uh, database to improve the performance of the application. So, so when they use cache layer in between application and database, the primary source of the data of the cache will be from the data just private database like Oracle or any database. Some examples of cache could be Redis and cache, so on. Caches. So when you use cache, the read operations will be done from the cache layer, and the write operations in the database. So what are the problems with conventional cache in with this? So now you understand what is cache layer and what is application, how cache layer improve the performance. So now let's discuss about the problems with conventional caches. So the developers are responsible for loading the cache. So whenever the loading the cache, so whenever we start the application, the developers are responsible to load the cache during the application start. And again, cache consistency with the database. Cache consistency with database. So developers are responsible to maintain the consistency of the cache with the database, because cache will be having only if any writes or updates happen on the in the database, that data will not be available in the cache. To maintain that updates are also synchronized with the cache layer, developers are responsible to write some custom code or any manual code to update this data. And also cache consistency with other caches. Cache consistency with other caches. So there are application layer will application in many applications will not be having only one cache, they will be having multiple caches. So there might be some synchronization or consistency between the all the caches whatever we are using the with the application. And again complex data type support. So most of the caches like Redis or Unicality will not support all type of data type formats. So it is again developer responsible to write some custom code or you do some customization to or any conversions to support the data type. And again high availability. So for high availability also they have to the developer has to write custom code to uh, to maintain the high availability of the cache. And the developers are responsible for maintaining all these data with the cache, and they have to take care of all these responsibilities, loading the cache whenever the application starts right. The cache layer should be loaded with the data, and again. If any cache miss happens, cache miss in the sense, if the data is not available in the cache layer, it has to fetch from the database that we call it as cache miss. So in that scenario, the application developer has to write some custom logic to fetch the data from the database whenever it is not available in the cache. And also the problems with this cache layer are missing security features like user management, uh, encryption, object level security, row level security. These all security features most of the cache layers will not be supporting. So for those security features, developers has to write some custom code to maintain the security features. And also developers are responsible then to write some custom code to keep the cache in sync with the database. So these are all like the problems or dependencies of conventional caches. So to resolve all these problems, these all problems, developers are responsible and their workload gets increased to take care of this all manual activities. They have to take care of a lot of things when maintaining this multiple caches or cache layer between the application and database. So the solution for all this manual work is true cache. Oracle true cache is a in-memory, consistent and automatically refreshed scheme and object cache independent of working address. There is a in-memory component which significantly looks like actually it is a like just like it handles all the SQLs or select SQLs like Oracle managers. Like conceptually, we can call it as a diskless active standby data guard standby, active data guard standby. In the sense, diskless in the sense it is only a true cache is a conceptually like diskless active data guard standby. So it doesn't take any disk storage for any data like table spaces, data files. Like we does not need any memory for storing those files. It only needs memory for configuration files like server parameter file, p file, control files, and read log files. So why? Uh, so the how the data true cache looks like. True cache is a memory component schema. So, so all these problems with the conventional caches were resolved by true cache. So how it looks like, this is application, how the true cache is maintained. So this is application, and again in between here we have database. Here we have true cache instance. So all the read operations will be going to true cache instance, and write operations will be coming to database. So this is how true cache is. True cache architecture. True cache is nothing but a compute instance where the Oracle software is installed, and we configure the true cache service on this machine. So on that machine, right, we have only basic configuration files like server parameter file, read log files, control files, and this true cache serves for all the read operations or any select operations. So whenever the database gets started, the true cache instant is started, it will automatically load the cache with the database. So whenever it loads the data, suppose if there is any cache miss happens with the true cache instance, it will fetch the data from the database. So if data is not available in the true cache, it will fetch the data from the RDBMS backend Oracle database. So when when it fetches the data from the Oracle database disk level, it will also fetch the along with the requested data, it will also fetch the surrounding blocks or surrounding data of that requested data to the true cache layer, so that the future queries will be near to that data will be served very quickly, and it will be available in the cache. And also the application can maintain the multiple true cache instances for one database. This can also use for read operations. So if you consider, you can also rebalance the load on the database server by distributing the suppose if you have this application, right, if it is for used for sales, suppose we can use this for HR application something. We can also distribute the load of the read operations from two multiple true cache instances. So this is how true cache looks like, architecture looks like, and this is how when we configure true cache instance, it will So what are the advantages of this true cache instance for the developers? This is purely for the developers' future. So the problems which we had with conventional caches, right? The loading the cache will be automated in this cache. And the cache consistency with the database is maintained is automatically maintained database, and also cache consistency with other caches is also maintained automated. Complex data types is automated. As this feature was with the 23AI, the 23AI supports multiple data formats like JSON data, vector data, and graph data, and all it as it is a convergent database. So we can support true cache, can support all the data types, and also security reasons. So database is only having encryption, row level logs, table level logs, and everything. So when data masking data, so only security has been taken care automatically, and also IO level is also taken automated. So is taking care. So these are all the different types of different tasks which are automated with the true cache, and it will reduce a lot of the manual work which developers do with their applications. And it also we can also increase the scalability of this true cache instances by adding multiple true cache instances to support multiple to distribute the load of the different applications to different instances, true cache instances, so that the load on the database will reduce. And also to improve the performance of the application, we create true cache instances near to the closer to the application, so that the latency between the cache true cache and application will be very minimal, and it will improve the performance of the transaction situation. So we can also the proof catchy can also be deployed usually in the cross region. Suppose if we have a cross cloud catchy, we also can use this as. Suppose if we have a database in one region, you can deploy the proof catchy in another region. Suppose if we have your database in India, you can and your application is in America, you can create a true catchy instance in America so that the catchy will be near to the application so that and the performance will be improved very fast. And benefit to the applications when using this tool catching. With this tool catching, companies can many organizations can save their cost by without relating any application code and without relating anything in the traditional products or catching products. Because we're already using database, and this is the future of this true catch is the future of Oracle database. So you don't need any full products within the catching, and any skill set or any other further skill this catching. And so uploading the catchy to this catching, upload the catching to this really hardly. Also, it provides a stronger security with some Oracle database and we leverage the powerful form of Oracle database. So this is all about catching, and what we can use is catching many areas like financial institutions, marketing, trade, mobile phone manufacturing, stock exchange. There, the data, we get the data to improve the performance of the data retrieval. And the key takeaways with this book actually is the most key takeaways is that automated data refresh. We can keep the data we can catch it. Full Oracle database this, and it supports edge AI vector to enable semantic catching. So with this true catchy, we can also do semantic search and relational search as the Oracle 23ai is a converged database. So this is on about Oracle true catchy.